Today's lesson is going to be focused on one topic called conditional probability. So let's take a look at what a conditional probability is. It's a probability that takes into account a given condition that has already occurred. So in other words, something has happened previously. We know that this has happened, and now we're trying to find the probability that something else happens. The notation for conditional probabilities is this little guy right here. We read this as the probability of the probability of B given A. That little straight up and down line, that is the word given. So you're given that A has happened. You know that, it's in the back of your brain. Now you're trying to find the probability of B happening. So to find the probability of B given A, we are going to restrict our attention to only the outcomes in A. You're only focusing on A because A has already happened. We then find the fraction of those outcomes in B that also occurred. So there's a formula for finding conditional probabilities. The probability of B given A is the probability of A and, if you remember that U from before, probability of A and B divided by the probability of A. Also, we've used the word independent in the previous chapter. We are now instead going to be able to prove whether two things are independent. And in order for two things to be independent, the probability of B happening has to equal the probability of B happening given A has already happened. We're going to use this little part here in our examples a little later on. So we're going to start by focusing on this formula right here. So turn the page and let's look at an example. 478 Michigan elementary students were asked whether their primary goal was to get good grades, to be popular, or to be good at sports. The results are broken down in this table. So obviously you can see grades, popular, or sports. They also separated it based on boys and girls. So we have several questions we're going to be answering. The first one is just a very straightforward question. Find the probability that a randomly selected student is a girl. Now, this is not a conditional probability. This is just from previous chapters. What's the probability that we selected a girl? Well, how many girls are there? Well, if we go all the way over, we have 251 girls out of how many students? Well, we know the overall total is 478. Now, can we reduce that? If you have one of my calculators, you can simply type in 251 divided by 478, math, enter, and it will show you that that is already reduced. Now, we're going to look at another question. Find the probability that a randomly selected student is a girl whose goal is to be popular. Well, some people are like, well, is this a conditional probability or is this a regular probability? The word is a big signifier. When we are doing these problems, we're thinking of kind of a fraction here. The is part is always the numerator. Okay, is like the division bar. The stuff after the is on top. The stuff before the is on the bottom. So before the is just a randomly selected student. So we're talking about all of the students. So all of the students was a total of 478. So we just need to find the number that is girls and popular. Well, girls and popular is that 91 right there. So we have 91 out of 478 students that are girls who want to be popular. And again, if you try and reduce that in the calculator, it is already reduced. Now, we haven't seen anything conditional yet. We're going to go to the next slide, same example, same table, and we're going to look at some that are a little more specific. Part C here is asking us to find the probability of selecting a student whose goal is to excel at sports. So there's the magic word is. Before is, we're just finding the probability of selecting a student. So we're still focusing on all of the students. So 478 is still the denominator. But now we're looking at students who want to excel at sports. So if we find the sports, we go down to the sports total, that is 90. So we're doing 90 out of 478. Well, for the first time, we know this is not reduced. 90 and 478 are both even numbers. They can both be divided by 2. If we divide them both by 2, we end up with 45 out of 239, and that is the reduced answer. Now, here's where we're going to get into conditions. Find the probability of selecting a girl whose goal is, there's the is. But notice, before the is, it doesn't say selecting a student. We are finding the probability of selecting a girl. So our denominator now, because remember, our fraction is after the is on the top, before the is on the bottom, our bottom is only girls. So these numbers all right here are all of our girl numbers. Those are the only numbers you're allowed to use. So the total for girls is 251. Now we're looking at girls who want to excel at sports. Well, the ones that want to excel at sports is that 30 right there. So it's 30 over 251. And that is reduced. So now we're going to look again. Find the probability that we have selected a girl, new word, given. Okay, so we don't have an is this time. Okay, we are being given something. When you have the word given, the given is always on the bottom. So we are being given that the student's goal is popularity. So this time, we are only focused on the popular students because that's what we were given. That's the prior knowledge, so to speak. So the given total for popular is 141. We want to find the probability that we've selected a girl out of that little bunch. So the girl total is 91. So 91 girls want to be popular out of all of the people that want to be popular. So when you hear the word given, the given is always the denominator. It's what we know ahead of time. So let's look at another example. A survey of college students found that 56 live in a campus residence hall, 62% participate in a college meal plan, and 42% do both. While dining in a campus facility open only to students with meal plans, you meet someone interesting. What is the probability that this person lives on campus? So our main goal is to answer the question, what is the probability that this person lives on campus? But there is something that we know is happening prior to that. You are dining in the campus facility, and it is only open to students with meal plans. This right here, only open to students with meal plans, is something that we know up front. You're doing this already. You're in the dining hall. Only students with meal plans get to eat there. This is what we would refer to as the given. Okay, we are being given the fact that only students with meal plans are eating there. So when we write it out, if you remember, it was always probability of B given A. We're focusing on the probability that the given is they have a meal plan. What we're trying to find is the question, a little squiggly. What is the probability that this person lives on campus? So we want to find out the probability they live on, whoops, some bad handwriting. Let's try that again. We want to find the probability they live on campus given they have a meal plan. Well, let's look back at our original formula. If you remember this formula from 2 slides ago, it was the probability of B and A divided by the probability of A. That's what the original formula was. We're going to apply that formula. So let's focus on the denominator first. We want to find the probability of A. A was our given, so our given is they have a meal plan. We'll look back up in our little stuff there. It says 56% live in a campus residence hall, 62% participate in a college meal plan. That's what we need to write now, right there. They have a meal plan. That's 62%. Well, we're going to write that as a decimal, so we're going to write it as 0.62. The numerator is the probability of B and A. So the probability they live on campus and they have a meal plan. Well, if we look up in our word problem again, it says 42% do both. So that would be 0.42. Well, if you have one of my calculators, you can type in 0.42 divided by 0.62. You can do, again, math, enter, enter, and it will automatically reduce it for you, and that reduces to 21/31. So that is a straight application of the equation that we used earlier. So let's take a look at another example. In its monthly report, the local animal shelter states that it currently has 24 dogs and 18 cats available for adoption. 8 of the dogs and 6 of the cats are male. Find each of the following conditional probabilities if an animal is selected at random. Well, if you notice, I gave you a blank table. We actually have to fill that in. So if you look through what we just read, we heard something about dogs and cats, and then we also heard something about male, which means we also have females involved. So those are kind of my main topics. So I either have dogs or we have cats. And those dogs are either going to be male or female, as are the cats. And so these last columns and last row are going to be your totals. So what do we know? Well, let's look at the first sentence. It said the local animal shelter states that it currently has 24 dogs. That's the total number of dogs. So I'm going to find the dogs. I'm going to go straight down, and I'm going to put a 24 here for the total. It says they have 18 cats available for adoption. So I'm going to find the cats. I'm going to go straight down, and I'm going to put an 18 there. So now we have specifics. Looking at the second sentence, 8 of the dogs and 6 of the cats are males. So dog and male, this box right here, I'm going to put 8 dogs and male, and 6 cats and male go there. Well, now we just got to do a little bit of algebra. If you have 8 male dogs and you have 24 total dogs, 24 take away 8 leaves us with 16. If you have 18 cats, 6 of them are male. 18 take away 6 leaves us with 12. So to finish up our other totals, we have a total of 8 plus 6 is 14 male animals. 16 plus 12 is 28 female animals, and our overall total, 14 plus 28 is 42, and we can also verify that 24 plus 18 is 42. So now that we have our table, we can now answer the questions that go with it. We are trying to find a probability that the pet is male given, there's our given that it is a cat. Remember, your given always goes on the bottom. So we're being told that it's a cat. Well, how many total cats do we have? Cats, if we go down to their total, that would be 18. So the numerator is the given, which is cats, and what we're trying to find. And we're trying to find male. So the number of cats that are male is 6. And so that reduces, 6 out of 18 reduces to 1 out of 3. So I would like you to pause the video for a moment, and I would like you to try B and C on your own, and then we'll see how you did. Okay, so let's check how you did. We are trying to find the probability that the pet is a cat given that it is female. So our focus, first of all, is females. How many total females were there? Well, there was 28 total females. Well, of those 28 females, we want to find out what's the probability that we have a cat. Well, there are 12 cats that are also female. So 12 out of 28 was your starting fraction, but we can reduce both of those by 4, and it reduces to 3 out of 7. Let's see how you did on the last one. We want to find the probability that the pet is a female given that it is a dog. So our given is dogs, so our total dogs are 24. So, and then our numerator, we're trying to find the probability that we have female dogs. So the number of female dogs is 16. And those are both reducible by 8, which reduces to 2 over 3. All right, so let's turn the page. Let's keep looking at some more examples. We have a little table here. It says the table shows the political affiliation of American voters and their positions on the death penalty. A voter is chosen at random. What's the probability that? So as you can see, we have political parties, Republican, Democrat, and other. And then we have either they favor the death penalty or they oppose it. Now, if you notice, there is one thing that's missing in this table, and that's the totals. So let's do all of our totals. I'm going to start by adding down. 0.26 plus 0.12 plus 0.24 is 0.62. 0.04 plus 0.24 plus 0.10 is 0.38. Now we got to add across. 0.26 plus 0.04 is 0.30. 0.12 plus 0.24 is 0.36. And 0.24 plus 0.10 is that's not working. Try that again. Is 0.34. Okay, so let's take a look at our original question. Oh, wait a minute, we forgot the overall total. 0.62 plus 0.38 just happens to be 1. Why do you think this adds up to 1? Well, because they're all percentages, and 100% is the same thing as 1. So the first question is straightforward. We simply want to find the probability that the voter favors the death penalty. So it's just asking what was the total for favoring the death penalty. Well, that was 0.62. And since the total is 1, 0.62 divided by 1 is just 0.62. So that was an easy one. Now we want to find the probability that the person we chose is a Republican who favors the death penalty. So we need to go to Republican, we need to go to favor the death penalty, and we get 0.26. Well, this is again out of everybody because there's no givens, there's no prior knowledge, so this is still out of 1, so we know it's 0.26. Okay, so now let's do a little more thinking here. We are looking for the probability that a voter who favors the death penalty is Democrat. So there's the is. If you remember, after the is on the top, before is on the bottom. So let's do the before. Before the is, we're looking at voters who favor the death penalty. So the people who favor the death penalty, the total was 0.62. Now we want to focus on the Democrats who favor the death penalty. And so that is 0.12. And so this needs to be reduced. So 0.12 divided by 0.62, math, enter, is 6 out of 31. Final part of this question, and then we have a couple more examples to go. A candidate thinks she has a good chance of gaining the votes of anyone who is a Republican or in favor of the death penalty. What portion of the voters is that? Well, if you notice, we have the word or. We've seen the word or before. We know that or means add. So we're simply adding the portion that is Republican and the portion that is, whoops, I circled of. And then we're also adding to it the portion that favored the death penalty. So let's start with Republican. What is the total for Republican? Well, that was, Republican was 0.30. So that was those numbers. The total for favoring the death penalty was those numbers, which was 0.62. But hopefully you're stopping and saying, wait a minute, we just used a number twice. If you remember back to the previous lesson, if you do an or and there is overlap, you have to subtract the overlap. So we counted this number, 0.26, this guy right here, he got counted twice. He can't be counted twice. So we're going to subtract 0.26, and we end up with an answer of 0.66 for this problem. All right, so we have two more. 56% of all American workers have a retirement plan, 68% have health insurance, and 49% have both benefits. We select a worker at random. What is the probability that the work has, and we have some questions to answer. I'm giving you a Venn diagram. That should be your big clue that you are going to use a Venn diagram here. So what were our two options? They either have a retirement plan or they have health insurance. So what did we know? We always start in the middle. How many people had both? Well, that was 49%. So this is 0.49. Now we're going over to let's do the retirement side. We knew, and it is there, but it's in word form, 56% of Americans have a retirement plan. So if you remember from the previous lesson, we need to take the 56, because that's the entire circle. We need to subtract the 49 that's already in the middle, and that leaves us with 0.07. Health insurance, same thing. What was the percent? It says 68% have health insurance. So we're going to take the 68% that we know have health insurance, subtract the 49 from the middle, and that's going to leave us with 0.19. And then the only other thing we need is that little outside region So if we take 0.07 and 0.49 and 0.19 and we add them up, we get 0.75. So the portion that's still left over is 0.25. All right, so we have everything now. So let's start looking at our questions. The first question is, what's the probability that the worker has neither health insurance nor a retirement plan? So this is neither of the circles. This is the leftovers, which was 0.25. And that's all there was to that question. Now we're asking, what's the probability that the worker has health insurance if he has a retirement plan? Well, we haven't seen the word if, but it's actually an important word. What word have we been using that we could put there and it would sound exactly the same? Hopefully you're thinking the word given. What's the probability that the worker has health insurance given he has a retirement plan? So I'm going to write the word given here instead, because we know that given always goes on the bottom. So what's the probability that they have a retirement plan? Well, the overall retirement plan was 0.68. No, I'm sorry, 0.56. I'm really messing up today. I looked at the wrong number. 0.56. What is the probability that the people have a retirement plan and they have health insurance? Because that's what goes on the top, is the people that have both. And that is 0.49. So to reduce that, put it in the calculator, math, enter. You should get 7 out of 8. Are having these two benefits mutually exclusive? Now we've seen that vocab word. Mutually exclusive meant that nobody is in common between the two groups. And as you can see from the Venn diagram, there's definitely people that fall into both groups. So no, this is not mutually exclusive. We know that 49% have both. Are having health insurance and a retirement plan independent? So on the very first slide, when we first talked about independent or conditional, we said there's a way to prove independence, and it was the probability of B has to equal the probability of B given A. So it doesn't matter which one you label which. So let's let health insurance be the B and retirement plans be the A. So the first half of this, what's the probability that they have health insurance? Health insurance, if you look back at the beginning, was 0.68. That's all we have to do there. So now on the other side, we need to find the probability that they have health insurance given they have a retirement plan. So, givens always go on the bottom. So the retirement given, if you look back up in your words, was 56%. The numerator needs to be the both. So what's the probability that they have the retirement plan, which we know is a given, and they have health insurance? That was 0.49. Well, if you want to see if the two are equal, we got to have them both in decimal form. So 0.49 divided by 0.56 is 0.875. Are these two numbers equal? And the answer is they are definitely not equal. So that means that they are not independent. Okay, so let's look at our very last example. You guys pause the video for a second. You guys do the Venn diagram and answer parts A and B. We'll do C together. So let's see how you did. It says according to example 4, so we've actually seen this Venn diagram before. It was the U.S. residents have traveled, the probability the U.S. resident has traveled to Canada is 0.18, to Mexico is 0.09, and to both is 0.04. We've done this problem before, so let's remake that Venn diagram. Make sure you did it correct. I can't spell Canada. So we got Canada, Mexico. The both number was 0.04. Canada, you should have taken 0.18 minus 0.04 to get 0.14. Mexico, you should have taken 0.09 minus 0.04 to get 0.05. And the leftovers on the outside, if we add all of those up, 0.14, 0.04, and 0.05 is 0.23, which means we have 77% left over. So let's see how you did on A. What's the probability that someone who has traveled to Mexico has visited Canada too? So it's a little wordy. Let's see how you did with that. Did you realize that one of those was a given? We are trying to find what's the probability find the probability that someone who has traveled to Mexico. So they've already done that. This right here was your given. So we know that Mexico is on the bottom. Well, what's the probability that they've traveled to Mexico? That will be 0.09. Then we need, the numerator is Mexico automatically and Canada. So the both part was 0.04. And if you put that in the calculator to reduce it, 0.04 divided by 0.09, math, enter, you get 4/9. So maybe you got that one right, maybe you didn't because it was a little wordy. Are traveling to Mexico and Canada disjoint events? Well, if you reference back, disjoint what meant the exact same thing as mutually exclusive, which meant they couldn't have anything in common. Are there people in common between Mexico and Canada? And the answer is yes. So no, these are not disjoint because 4% of the people went to both places. So now we're answering a similar question to what we just did on the previous example. Are traveling to Mexico and to Canada independent? So to be independent again, the probability of B has to be equal to the probability of B given A. So let's let Mexico be B and let's let Canada be A. So first part, what's the probability of just Mexico? Well, that's easy. Mexico is 0.09. Now we have to find the probability of Mexico given Canada. Notice I said the given is Canada. So Canada is the requirement, which is 0.18. But then the numerator is Canada and Mexico, which is 0.04. And so if we divide 0.04 divided by 0.18, we get 0.22. So the big question is, are these equal? 0.09 is definitely not equal to 0.22. So Mexico and Canada are not independent. And that is the end of your lesson, and you will be doing homework in class.